Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at transformations of parabolas. What we're going to be doing is graphing equations of this form. So this has an x and a squared. So this is a quadratic equation. Its graph will be a parabola. So we've looked at using table of values, but we understood that there were some issues with that. Namely, they can't always tell us the turning point, intercepts, and things like that. So we need another way to graph. And what we're going to do is use transformations. We learned also in a previous lesson, we can compare the graph of any parabola to y equals x squared. This is the simplest parabola. But when we graph something that has an equation that looks like this, we're essentially just graphing y equals x squared, but we're shifting it left or right, or up or down. We're performing transformations to this graph. So we learned in a previous lesson that this number here shifts the parabola left or right, but it goes the opposite way that you'd expect. If this one's positive, it shifts the parabola left. If it's negative, it shifts it right. This number outside the brackets shifts the parabola up or down. It works the way you'd expect. Positive means up, negative means down. So what does it mean to shift the whole parabola left or right, up or down? Well, really, we're talking about moving the turning point. For y equals x squared, the turning point is here. It's the origin. So h will move the turning point left or right. K will move the turning point up or down. So putting this all together, if you have an equation of this form, then the negative of this number is the x-coordinate of the turning point, and this number is the y-coordinate of the turning point. So to graph any parabola of this form, we just apply the transformations, and then we find its turning point. We first plot its turning point. But one point is not enough to graph a parabola. You need another point. So to find another point through which the parabola passes, we're going to find the y-intercept, and you do that by letting x equal 0, because x is 0 all along here. That will tell us the y value. Does it hit the y-axis here, 5 or -1 or whatever? So just graph the turning point, graph the y-intercept, and then we can draw the parabola. All right, let's look at some examples. So let's say we have y equals 2, x minus 1 squared plus 3. So first thing we're going to do is we are going to plot its turning point. So the turning point of this graph we get from this value and this value. So the turning point is the negative of this value. So that's -1, -1, it's +1. It's like the opposite. If this is negative, then this is positive. This is positive, this is negative. So the turning point is going to be 1, and then we just take this number as it is, 1, 3. The turning point of this parabola will be over x equals 1, y equals 3. It will be up here. So we've plotted the turning point. Now we need to find the y-intercept. So to find the y-intercept, we let x equal 0. So for this one, if x equals 0, we get 2 times 0 minus 1, -1 squared, make sure it's in brackets, plus 3. So if x equals 0, we get 2 times 1 is 2, plus 3 equals 5. So this graph here, y equals 2 outside of x minus 1 squared plus 3, it has a y-intercept of 5. So it goes through that point there. So that's actually enough for us to draw the parabola, given that we know that this is the turning point. See, the parabola is going to come through here, and it's going to stop at the turning point and turn around and go in the other direction. Now remember, every parabola has an axis of symmetry, a vertical line going through the turning point. So it'll be symmetrical about this line. So because we have a point here that's 1 across 2 up, we'll also have one that's 1 across 2 up. It will also go through that point there. So hopefully now you can see the shape of the parabola is this. And here we have the graph of the parabola. You should write the equation on it and put some arrows there as well. So this one's done. Let's turn our attention to the red one here. Y equals negative x plus 2 squared plus 1. So first thing we are going to do is we are going to plot its turning point. So the turning point here, it's always the negative of this. So that's 2, positive 2. So negative 2 goes in the turning point, and then we just take this number as it is. So this graph here will have a turning point at negative 2, 1. So we go across to x is negative 2 and up to y equals 1. That is the turning point. Again, that is not enough to know about the shape of the parabola. It could go like this, it could go like this, could be fatter, could be thinner. We don't know. We need another point. So we're going to find the y-intercept by letting x equal 0. So if I substitute x equals 0 here, so we would have y equals negative, and 0 plus 2 is just 2, so negative 2 squared plus 1. So we have negative 4 plus 1. That gives us negative 3. The y-intercept of this graph is at negative 3, so we plot that there. So this is really all we need to graph it, but if you want another point to help you out, remember that because this is the turning point, this is the axis of symmetry. It's symmetrical about this line. So this point, we go to the axis of symmetry 2 across, so we go 2 across again. The parabola will also pass through this point, negative 4, negative 3. So we can put that point there if you need. So then we just join up the points in this parabola shape, making sure we put on arrows on each end, and we write the equation. So then we're done. That's all there is to graphing parabolas. Let's now look at the opposite, where you're given the parabola and you have to find its equation. So this time we have a parabola, we have its graph, and we are going to use that to find its equation. We're saying, what equation do you start with so that you would end up with a graph like that? Well, we know that the equation is going to be of this form. Any parabola can have its equation put in this form. So all we need to do is find the values of a, h, and k. Now, hopefully you remember from the previous slide, the turning point is going to be at negative hk. So because of that, we can go to the turning point of this graph and we can find h and k very easily. So the turning point here of this graph, you can just read off as negative 2, 3. So what that means is k is going to be 3, but negative 2 is negative h. H is going to be positive 2, because remember, if you want to go 2 to the left, you need a positive 2 in there. So what we've actually found is that this will have equation y equals a, x plus 2 squared, plus 3. Remember, with the turning point, this value and this value are always opposites. They're the same number, but a different sign. So we're almost there. We found h and k, but we need to find a. How do we find what a is? Well, all we do is find another point and substitute in. I'm going to take this point here, the y-intercept at negative 5. What I'm going to do is sub in the point 0, negative 5. At this point, x equals 0, y equals negative 5. So change y to negative 5 and x to 0. So that gives us y equals a, x is 0, plus 2 squared plus 3. So let's just clear that up a bit. So we get negative 5 equals a, 0 plus 2 is 2, 2 squared is 4, and then plus 3. Now you know how to solve these equations. We're going to subtract 3 from both sides, and then we divide each side by 4. So I get a equals negative 2. So now I found a, I already had h and k. Now I know the equation of this whole parabola. It is y equals a, x plus h squared plus k. This is the equation you'd start off with to end up with a graph like that. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.